I want to look at an example that involves implicit differentiation. In particular, I want to find y double prime where x to the fourth plus y to the fourth equals a to the fourth. So y double prime means I need to find the second derivative. So first of all, we're going to apply the first derivative. I'm going to take the derivative with respect to x of all of this. So since x is the variable, the derivative of x to the fourth is simply 4x cubed. But the derivative of y to the fourth is not simply 4y cubed. It's 4y cubed times whatever the derivative of y is with respect to x. So you have to use chain rule. And in general, in implicit differentiation, anytime you have y to a power, you have to apply chain rule. Alright, now a to the fourth is a constant, so its derivative is 0, so that part's not too bad. So then I can solve this equation by subtracting the negative 4, or subtracting by subtracting 4x cubed from both sides, so I get negative 4x cubed, and then dividing both sides by 4y cubed, I end up with negative x cubed over y cubed. That's my derivative. Okay, that's dy dx. Or we might say here y prime. Now I'm not trying to find y prime, I'm trying to find y double prime. So to find y double prime, I take the derivative of what I just found with respect to x. So here they have, since I have negative x cubed y cubed, I need to use quotient rule. So that's going to be low. So I'll say y cubed times the derivative of the top, which is negative 3x squared, minus the top, so it ends up becoming a plus x cubed, times the derivative of the bottom, which is 3y squared y prime, all over the denominator squared. So that's going to be y to the sixth. Y cubed squared is y to the sixth. Okay, now this doesn't count as an answer because I have a y prime, and I want to write things in terms of x and y. So I need to substitute. Well, I know exactly what y prime looks like. It looks like negative x cubed y over y cubed. Okay, so if I plug that in, I get y double prime equals, let's see, we get negative 3x squared y cubed plus 3x cubed y squared times negative x cubed over y cubed all over y to the sixth. Okay, and that's a y cubed in that denominator there. Let me rewrite that. Okay, now how do you simplify this? Let's multiply, since I don't like this y cubed in the numerator, since it's in the denominator within the numerator, let's multiply everything by y cubed over y cubed, and I'm going to distribute this across, and when I do, it's going to take care of the problem here. So I have y double prime then equals negative 3x squared y cubed times y cubed, so that would be y cubed times y cubed is y to the sixth, plus 3x cubed y squared with a negative x cubed over y cubed times y cubed, which ends up with a negative x cubed. So I can bring that together in a little bit. And then y to the sixth times y cubed, you add the exponents, you get y to the ninth. So finally, just cleaning this up, you get negative 3x squared y to the sixth minus 3x6 y squared over y to the ninth power. And there it is. There's my second derivative. So now if I have a position formula or a position function based off this, then I know that I can find the velocity based off this expression for any y and x, and I can find the acceleration based off what we just found, the y double prime, for any y and x. I hope this makes sense. Please let me know if you have any questions. I'd be glad to help. Implicit differentiation is not too difficult once you figure out how to apply chain rule correctly and how to, in this case, substitute in like we did right there. If you have any questions, let me know. I'd be glad to help, and thank you for watching.